Alright, so let's take a look at this first guy right here. And I gave you a lot of graph space so you can actually graph this. Now we want to graph absolute value of x. Now, what does the graph of an absolute value function look like? It looks like a V. And we could take this and say, all right, well, absolute value of x, if we want to graph it, it's going to come down to y equals x and y equals negative x. And so we're going to have to draw a coordinate plane here. So I'm going to draw a coordinate plane here. Now, where do these intersect? 0, 0. Now, if I put in a 1 here, well, I know I'm going to get 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. It opens up, doesn't it? All right, it's going to open up. We do use the same type of rules as parabolas. So it's going to open up. And so if we go through this is the graph of y equals absolute value of x. Now, what's my lower limit? What's my upper limit? All right, so I'm going from negative 3, 1, 2, 3, 4, 5, to 5. And so I want the areas here and here. So we get the area of two right triangles. What's the height of this right triangle? What's the length? 3. No, because it's a positive area. So it's 3 and 3. So we're just going to use the shapes. I know this is a positive area. That part's positive. That part's positive. Now what's the length here? And the height here is 5. Alright, so now area of a right triangle is equal to 1/2 leg 1 times leg 2. And am I going to add these areas together? I'm going to subtract them. Are they positive areas or are they negative areas? They're both positive areas. Thanks. Positive, it's above the x-axis. Negative, it's below the x-axis. So in this case, we're going to add these two areas together. So we have to figure out what these areas are. So my integral, let me zoom it out just a little bit. My integral is going to be, well, from negative 3 to 5 of the absolute value of x dx is going to be equal to area 1 plus area 2, 1/2 times 3 times 3 plus 1/2 times 5 times 5. So if we don't have a rule per se, we can actually figure out the areas by just figuring out geometric parts underneath it. Now this is going to be 9/2 plus 25/2, which is 34/2. Which is how much? 17. Or 7 units squared. That's a good question. Couldn't tell you. We would have to actually break it up and take the integral from... This is one of those functions that is kind of a pain, because we would have to break this up and say from -3 to 0, it's going to be y equals -x. And so we'd have to integrate -x in that case for this part of it. For this part of it, we'd have to integrate y equals x from 0 to 5. So we'd actually have to break it up into 2 parts. So it's not a neat formula type of thing to find an antiderivative for it.
So if we get an absolute value probably from a test, you recommend this way instead of...
Yes, because if I give you an absolute value integral on a test, it's going to be on a non-calculator part of it. All right, so that's example 1. Yeah. No, could be part of it. Now, how do you go about graphing an absolute value equation when it's just not x, when it's a little bit more than x? What do you mean? Well, you could do that. Well, yeah, in this case, it's going to be positive. So, I want to go from 0 to 8. Now, if we're doing that, you can just kind of plug in values and go from there. You can say when x equals 8, what's the absolute value of 2 times 8 plus 3? 19. When x equals 0, what do we get? Absolute value of 2 times 0 plus 3 is 3. Now, where is this going to be equal to 0? If we're trying to think of I'm getting this to do another